Okay, so before we get started, Erica?
Okay. Are you a banker? Because I'd love for you to leave me alone.
That's awesome. That's awesome. Guys, not something you want to hear. Or girls, for that matter. All right, let's get started. So, we are going to start with labeling a triangle. Not all triangles are not going to be triangle ABC. They could be XYZ. They could be alpha, beta, gamma. It doesn't matter how it's labeled, but this is the system we're going to use. By system, I mean the vertices are labeled with capital letters. The sides are labeled with lowercase letters. The lowercase letters are always opposite the vertex. So in other words, if angle A is over here, then side A is going to be opposite that angle. If vertex B is up here, then side B is going to be opposite B. And if vertex C is over here, then side C is going to be opposite that. Okay. Pretty easy. You got to be sure to get that right though, because when we start talking about a triangle, if I give you triangle DOG and ask you to find side G, you're going to have to know where G is without a diagram. And so in other words, be able to draw a right triangle and find those sides. This is going to be true for any triangle. However, this trigonometry that we're covering now only works for right triangles. Eventually, by the time we get done with this chapter, we'll be able to work with any triangle. But initially, the trigonometry that we're going to use, like I said, is only right triangle. So you got to be sure to check to see if it's a right triangle. And we've talked about how to do that already. What trig will also do for us is allow us to work with triangles that we haven't been able to work with. So we're pretty much pigeonholed at this point with a 30-60-90 or a 45-45-90 triangle. This will open it up and allow us to work with any triangles. Okay, we good? All right. The trigonometric things are functions. And functions all work the same. You've been working with functions since kindergarten and probably even before kindergarten. Addition, subtraction, multiplication, division are functions. Squaring is a function. Square rooting is a function. And the function is very simple. It takes a number, it does something mathematically magic to it, and it spits out another number. That's how you need to think about functions. Even in 3 years when you're in calculus, I still explain the same thing to my calculus kids. Don't overcomplicate this. Okay? It puts in a number, it does some magic, it spits out another number. Okay, so if it's a squared function, you put in the number, it takes that number, multiplies it by itself, and spits out an answer. These are the same thing. For our purposes, we're not going to get real technical into where these things come from. That comes later in your math career. Probably junior year, you'll talk about where these actually come from. We're just going to get a working definition. Sine, cosine, and tangent. They are abbreviated SIN, COS, and TAN. Please don't call them sin, cos, and tan. Okay, that's just like a math faux pas. If you're out in the math community and you go, yeah, so I'm working on this problem and I take the sin of 25 degrees, they're going to kick you out of the cool kids club. All right. Sine, cosine, and tangent. We good? You've heard of these before, right? Notice on your calculator there's 3 buttons. You might as well find them now. They are above the parentheses and the comma. Sine, cosine, and tangent. You're going to be using those a lot. Here's our definition. Now, before you start writing like mad people, let me explain. These values, A, C, B, C, A, they're all based on this triangle. So if you want to include the triangle, that's fine. If you don't want to include the triangle, then just write leg opposite the angle over the hypotenuse. I would recommend writing the whole thing so you have an example of it there, but it's entirely up to you. In other words, the sine of angle A is not always going to be A over C. Suppose you're dealing with triangle cat, and it's labeled differently. I'll give you a second to write that down, and then we're going to talk a little bit about it and then dive right into some examples. Gesundheit. Can I talk while you write? Okay. To make your life very easy, I'm going to simplify this lesson as much as possible. For instance, these functions, there's a lot up on that screen that you're writing like mad people, but you need to just remember this. The sine, cosine, and tangent functions are simply ratios. That's it. Now, there's a lot of words up there and all this other stuff, but again, if you simplify it down to the bare bones, they are only ratios. Something over something else. Okay, we good? Is that a no or a yes?
No.
No. All right, here we go. Oh, by the way, as a reminder, you might hear people refer to SOHCAHTOA. Ever heard that before?
No.
Well, now you have. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, would that be a mnemonic? I think so, right? Yeah. Okay, so let's start with this guy. Got a triangle. First of all, how do I know that's a right triangle? What does that mean, George?
It has the box.
It's got the box in it. How else do I know it's a right triangle?
It's a 3, 4, 5.
It's a 3, 4, 5. What's that called, Jack?
A triangle.
No, what's 3, 4, 5 called? What kind of thing is that?
I can't remember.
Anybody?
Triple.
What kind of triple?
Pythagorean.
Pythagorean triple. Very good. Okay, so we know that's a right triangle. So therefore, the stuff that we've talked about already in the previous page, or slides actually, we can apply to this. So as I said, don't overcomplicate things. They're just ratios. So what, for instance, Natalie, is the sine of angle A? Over?
5.
Good. You want to explain that, or?
No.
No? Okay, good. We'll just leave it as that. Teach yourselves, kids. 4/5. Sine is opposite over hypotenuse. Which side is opposite angle A? 4. Which one's the hypotenuse? 5. So, cosine now of angle A. If I look at angle A, for cosine, I need adjacent and hypotenuse. But there's two sides adjacent to angle A, the 3 and the 5. Which one do we choose for the adjacent?
The adjacent leg.
The adjacent leg, right, not the hypotenuse. It's got to be the hypotenuse first. So therefore, the cosine of angle A, Caitlin, is what?
Oh,
Beautiful. Again, it's just a ratio. What's the tangent of angle A, Amber?
4 over 3.
Good. Opposite over adjacent. Any problems there? Okay, good. How about the sine of P, Jocelyn?
4 over 5.
Nope. What sine? How's sine defined?
Like opposite of angle A.
Okay, but we're dealing with angle P here. I think that's your confusion. So what side is opposite angle P?
3,
And which one's the hypotenuse?
5.
Good.
3 over 5.
Okay, what's the question?
Yeah, how do you know you're supposed to use the sine A, cosine A, tan A, are there different, do you see what I'm saying? Are there different, what's the word?
Don't think of it as being, like the sine being married to A. Think of it as just a sine function.
Okay,
So we're taking the sine of something. And that something means from that something, I want the opposite side and the hypotenuse.
Okay, so there's not like a sine B. It just, that's what
You just
sine
change, I mean, you could take the sine of smiley face. So what's the sine of smiley face? It's the side opposite the smiley face over the hypotenuse of that triangle with the smiley
Right,
face.
okay, so, cause on the board before it said like sine A, cosine A, is that just mentioning the different angles?
Yeah,
With
based
the
on that
example.
example triangle that
Okay,
I have.
thank you.
Okay, what's cosine of P? Brennan.
4 pi.
Good, and last but not least, Nathan, what's the tangent of P?
3/4.
3/4. Very good. Any problems there? Again, it's just a ratio. Now, do we really care about this? Well, this is going to get us what we want later, and what we want later is finding side lengths and angle measures. But we got to understand this before we move on. How about this guy? What's the tangent of angle E? Hey,
I have a question.
certainly.
Like, what are we gonna use this for?
Trigonometry? Are you asking like in the grandiose, like, where am I ever gonna use this? Is this
Well,
a
I'm
smart
just
aleck
confused.
question? Like,
No,
this is
no, it's
dumb.
not
Where am I ever
supposed to
gonna
be
use
smart.
this?
No, it's just like I'm confused on like why we're actually finding it.
Can you give me a couple slides? And then if I don't answer your question in those slides, then we can come back and address it.
Okay.
Okay, because I think I have the answer coming up. All right. What about the tangent of E? So tangent is opposite over adjacent. What side's opposite angle A? Angle E?
Hypotenuse.
The hypotenuse, which is 5. Which one's the adjacent side?
4, 3.
4 or 3?
Yeah.
Which one?
Can you have 2 answers?
I don't know, can you?
Probably.
So which one do you want to go with?
3.
3. Are we okay with that? I think there's a lot of math where you could just pick one or the other.
No, just do both.
Just do both?
Yeah.
Why not neither? Why can't we stay with his 5/3? Because that's the one he's feeling, right here.
Cause I don't know, it just seems more mathy to do both answers.
I'm sorry, did you just use the word mathy?
Yeah.
That which is like math?
Yes.
Wow. Olivia, what do you think?
No, I'm just wondering, cause like opposite of E is the hypotenuse, but it
I'm
says
with
it
you.
has to be a leg. So
Oh, so you don't like the 5.
I don't know.
So you're adding more complicated discussion to the argument. So we're okay with the hypotenuse being the 5, but now you're saying it's got to be the leg opposite, but that's not a leg, it's a hypotenuse, so that you don't like the 5 either?
I don't know.
Are you seeing that there's a problem here?
Yeah.
Okay, good. Let's talk about the cosine of E.
Which leg do you choose?
Hmm?
Which leg do you choose?
Which leg do you choose? They're both legs, they're both adjacent. Which one do you like?
Neither.
Neither. Good. Okay. How about the sine of E? Yes, sir.
Just like hypotenuse over hypotenuse, basically.
Which is?
One, but you can't have the hypotenuse over because it's leg opposite.
So you don't like 1?
No.
You understand the problems here, right? So you know how we deal with this?
Don't do it.
We don't. We just stay away from that. It's scary. Okay. So you don't want to be taking the sine, cosine, or tangent of the 90-degree angle. Okay. If something scares you, just avoid it. Except math. Never avoid math.
Very helpful.
It's scary.
All right, let's make sure your calculators are working correctly. There's a sine and cosine tangent button on your calculator. Hopefully you found those already. Type in cosine 41 and hit enter. And you should get 0.7547. I rounded to 4 decimal places. Did anybody not get 0.7547? Okay, that happens. So at the top, you see the mode button. The third one down says radians and degrees. You should be in degrees.
Mine is in degrees, and mine said something else. It was like negative.
You did the cosine of 41 degrees, and you're in degrees mode,
Yeah.
then you need a new calculator.
Negative 0.98.
No,
That's
that's
what I
what you
got
get,
as well.
that's what you get if you are in
How do you guys change degrees?
It just has
Mode, third one down, you should have degrees highlighted.
Oh wait, never
Yeah.
mind. So
Crazy.
I thought that like radian, and they're like, never mind.
So let's talk about fun practical jokes. I think we've talked about the first one already, changing the language of your friends' calculators. Have we done that yet? Okay, that's a good one. So I think it's under apps. You can go down and choose all the different languages. So you can put your friend's calculator like German or Spanish or
numbers are the same.
all these. What's that?
Aren't the numbers the same?
Well, for the most part, yeah. I don't think there's a Chinese or a Mandarin setting. But here's the other really good one. Like right before a quiz, change your friend's calculator to radians mode, because then they'll get all the answers wrong. That's really funny.
No.
Then they cry, and then we make fun of them because they're crying, and then. All right, check, make sure tangent is working correctly, and of course the sine are those three. There is no reason as a freshman in high school that you should be in radians mode. It's not like you're going to go to another class like AP Human Geo, and they're going to ask you to put your calculator in radians mode. Okay, so it should always be in degrees mode. Yes, sir.
So being degrees mode makes no difference compared to radian mode?
It does make a difference. You get the wrong answer.
No, for in this case, like if we set to degree mode, we get the right answers for this, but will it affect any other like math functions?
No. I hope. Depends on what, you doing any crazy math or
No, I'm just,
anything with angles will affect it.
okay.
Yes, sir.
Why don't we do degrees, not radians?
Great question. Because most people understand degrees better because you're used to it. So if you say to a third grader, how big is 45 degrees? Let me ask you a question. Where do you go when it's cold? Why?
Because it's 90 degrees.
No, because it's pi over 2 radians. See, that's really why we use it. Because then Erica's joke just doesn't make any sense.
Alright.
Okay, so, yeah.
Wait, what does taking like the cosine of 41 degrees mean? Like, I don't
That is a great question. This is what we call magic. Okay. So for our purposes, we don't want to have to figure out what this is. We just use the magic box, and it does it for us. You'll learn later where these magic numbers come from. And by the way, just a little slice of life here. Back in my day, we didn't have those fancy calculators. So if you see on the hall pass, see all these numbers? This is what's called a trig table. So if you wanted to take the, oops, it's upside down. And I don't have my glasses on. Let's see, where are we at? Here we go, trig functions. So if you wanted to take the cosine of 20 degrees, you would look it up on a chart. And you'd get an approximate value here. You really can't read it because the E's in the way, but you get the idea. This is actually a desktop. So a long time ago, this was your desktop. It sat in like a metal tray. So if you were doing trig, you'd have to flip your desktop over. If you're doing some graphing, you would flip it over and you get, so that's how we used to do trig, is you'd have to look it up on a big chart.
That's
Or it'd be in the back of your book. So you guys don't know how good you got it.
actually awful.
Yeah, it was horrible. And you can only get it accurate to like 3 decimal places. Yours would do it a gazillion decimal places. Yes, sir?
How long did it take you to carve that into the board?
Years. I didn't do it. One of my students did it for me. They put it in a fancy machine downstairs and done, like 2 minutes.
Nice.
Okay, so I didn't answer your question because that's not what we're gonna do in here. We're just gonna pretend it's magic.
But it is
Can you
magic.
at least like,
Something.
It's math.
That's a job for your advanced algebra or your pre-calc teacher to explain to you where those numbers come from. For our purposes, you can just think of it as it comes from a ratio. It comes from taking a triangle with a 41-degree angle in it and setting up a ratio between 2 of the sides. That's a simplistic answer. What do you got?
so there are 4 decimal places. Will we have to do that on tests too? It'll always be 4 decimal places.
Yeah, anytime you take a trig value you're gonna take it to 4 decimal places. Anytime we find a side length or an angle measure, 2 decimal places. Okay, let's move on. Now, why do we want to use this? Because we want to be able to solve this problem. Number 1, it's a right triangle. Number 2, it's not one of the special right triangles. It's not a 30, 60, 90. It's not a 45, 45, 90 triangle. So therefore, we have to use right triangle trig. Now, what's going to happen is the problem like this is going to show up on a test or a quiz. And if you're not careful, you're going to make the common mistake of assuming that this is a 30, 60, 90 triangle, even though there's a 40 there, and you will tell me that x is 1.5 and y is 1.5 square roots of 3. Don't do that. You have to use trig here. And I'm going to take you through the process step by step. It's a fairly simplistic approach, but I want to make sure that I'm figuring if we start simple, then when it gets more complicated, everybody will be with me. So as I work through the example, you might be like, oh, I get it. You know, why are we doing this? But just bear with me, because in the long run, it'll pay off. Okay, we good? We're going to deal with the 40-degree angle. Another rule of thumb, always work with given information, not calculated information. So we'll solve for x first. I've got this angle of 40 degrees, I've got x, and I've got the 3. Question number 1, what side is x with relationship to the 40-degree angle? Is it opposite, adjacent, or hypotenuse? Opposite. What do we know? We know the 3 meters. Is that the hypotenuse or the adjacent? Hypotenuse. What function uses opposite and hypotenuse? Sine. Good. So once you identify the trig function, set up an equation. The sine of 40 degrees is equal to x over 3. How do I solve for x?
Times each side by 3.
Say again, I'm sorry.
Times each side by 3.
Good. And the correct way to do this is write the 3 out in front so we don't mistake it as the sine of 40 times 3. Plug and chug. Give it to me. Somebody.
1.9284.
So 1.93
Yeah.
meters?
Yeah.
Do we agree?
Mm-hmm.
Beautiful. Hey everybody, it's Mr. Tranquil.
Hey, Mr. Trinkle. Mr. Whittemore would like to know if you want copies of the notes or homework and notes.
I'll take the whole kit and caboodle.
Whole kit.
Tell them packet it up for me.
Packet it up.
Yep.
Got it.
Thank you.
I guess if you want us to run it times 4.
No, trig values. If you take the trig value of an angle, that's 4 decimal places. Sides and angles, 2 decimal places. Does that answer make sense?
What does trig
Yes.
value like for the decimal places?
If I just ask you for what's the sine of 40 degrees, you take that to 4 decimal places. But this is a side length.
Oh.
So I asked a question, somebody said yes, who said yes? No one said yes. Okay, good, I must be hearing things. That happens every once in a while. Does that answer make sense?
Yeah.
Why? Good, magic.
Because it has to be less than 3.
Good, has to be less than 3. Okay, let's find y. From the 40-degree angle, is y the opposite, the adjacent, or the hypotenuse? Adjacent, and we also know the 3, which is the hypotenuse. What function uses adjacent and hypotenuse? Cosine. Cosine of 40 degrees is equal to y over 3. So 3 times the cosine of 40 is equal to y, and therefore y is equal to, will it be bigger or smaller than 1.93?
Bigger.
Why? Because I already punched it in my calculator and I know the answer is bigger than 1.93. Faith?
Because the angle is 50, and then across it, it has to be bigger.
What theorem is that?
Half that.
Is it like the small, medium, large?
Bingo, small, medium, large. What's the answer?
2.3.
2-point tree. 0, I assume, right? We're just dropping
No,
a 0.
It was 2.290.
9.
Okay, good.
We probably, I think we already had this conversation, but when do we put the 4 decimal place then?
Anytime you just take the trig value of an angle and that's it. Yep.
Isn't this the trig value?
No, this is a side length.
Oh, okay.
Yo.
If you're taking, do you ever just take the trig value of a side length?
Can't do that.
Oh, okay.
Yeah, that makes no sense.
Okay.
Yeah, you can't take the sine of 14 meters. That's how you'll also get kicked out of the cool kids math club, is
Okay.
if you start doing crazy things like that. Right. If you were to say to somebody, yeah, I solved that problem by taking the cos of 26 feet, you're out. You'll walk out of there crying. They'll just mock you into oblivion, and they'll probably even take your calculator batteries away from you.
Not the
And your sled.
batteries.
Yeah, the batteries. They would. I've seen it. It turns ugly. I mean, you hang around with those people and they're unforgiving. Yes, sir.
So if you've already solved for x, could you solve for y with Pythagorean theorem?
Excellent.
Would that be okay?
Excellent question. You can. Initially, I'm not endorsing it, but you can as long as you use a stored value. So another habit that you might want to get into is when I solve this when I solve this problem and get an answer, the very next step you should do is store that somewhere. Store it into X, store it into Y, store it into wherever you want. That way, if you want to do a calculation later with it, you have the stored value. It's better to store something and not need it than to need it and not have it stored. I think I said that correctly, didn't I?
Yeah.
We'll go with it. It's fine.
How do you do that again?
What?
If it's easy like this, couldn't you just, like, if you had it stored and then you realized that, or you didn't have it stored and then you realized you needed it, could you just do it again?
You could, but again, if you get in the habit when the problems get nastier, and they will, if you've got it stored, then you don't have to go back and do 47 steps to get that answer back.
How do you store it?
Stow,
Store.
stow,
Stove.
stow.
How do you stow it?
No, how do you store it? Stow. I wasn't being a smart aleck. It's
Oh, well, okay.
and then you just choose where you want to store it. So store, I usually use the X button up at the top. It's the X, theta, T thingy jobber. But you can store it under any letter you'd like. So like maybe you want to store X under X, but this is kind of crazy. You could store Y under X. Good. Idiots. Okay.
And we could store X under Y.
G.
Or you can store it under there.
Sure.
Okay.
Wait.
Wait, what?
Okay.
It's
I'll
having a
figure-
rough day.
I'll figure it out.
You okay?
Yeah. Okay.
Do you want to, okay. Let's make sure you got it under control. So hit 3, stow, X. See the X button up at the top? It says X, it's got an X, a T, a theta, and an N on it. Okay, now hit enter.
Okay.
All right, now hit,
I got it.
hit 7X on the home screen, and it should put out
21.
21, okay? Got it?
Yeah.
Beautiful. Okay, this is going to get a little bit more complicated for a couple of reasons. Number one, we changed the problem around a little bit. Number two, I flipped the triangle over just to make things interesting. Christelle, you want to start with R or S?
R.
R, beautiful. So, using the 15.5 degree angle, is R opposite, hypotenuse, or adjacent?
Opposite.
And we are looking, or we're given which side?
35.
Which is the adjacent or the hypotenuse?
Adjacent.
Adjacent. So what function uses opposite and adjacent?
Tangent.
Tangent, good. Almost got kicked out of the club. So the tangent of 15.5 is equal to R over 35 or 35 over R?
R over 35.
Good. So 35 times the tangent of 15.5 is equal to R. So therefore R is equal to bigger or smaller than 35? smaller, because 15.5 is gonna be smaller than that angle over there. 74.5, I think it is.
9.71.
Say again?
9.71.
Can somebody confirm 9.71?
Yeah.
Beautiful. 9.71 feet. Good? We good? So far? All right. Erica, side S. Is side S the opposite, adjacent, or hypotenuse? Good, and we know 35, which Christelle already told us is the adjacent side. So what function uses adjacent and hypotenuse?
Cosine.
Good. Cosine of 15.5 is equal to 35 over S. This one's a little trickier to solve. How do I solve that equation for S? Cricket. Amber,
No,
no, you lied.
I take it back.
Mm.
I was gonna say divide it.
You took back a hand raise.
Take it back.
I understand. Anybody else? Little basic algebra here?
35.
How is it?
Nothing.
How's it?
I take it back. Sorry.
You're taking another taking
Yeah.
back. That's two take backs.
Sorry.
Did you raise your hand? You were just doing some yoga or stretching? You know, shoulder cramp from all the writing? I understand.
Yeah.
Anybody else? Raj?
Could you do like negative S over negative 30?
Negative S over, no.
So you can't flip it, but it would be.
What are the rules of algebra? Whatever you do to one side, I could flip it if I want,
Yeah, flip the other
but then you gotta flip
side.
the other side. Is that gonna solve any problems? No. How do you get something out of the denominator? You just did it over here. How do you get something out of the denominator?
To multiply.
Multiply it. So what am I gonna do first? Multiply by S. So S times the cosine of 15.5 is equal to 35. How do I get S by itself? Divide. S is equal to 35 divided by the cosine of 15.5. You'll notice that the S and the cosine of 15.5 switch places after doing that algebra. Call that the switcheroo. And that answer is
36.32.
36.32. Does that answer make any sense? Yeah, it makes perfect sense. It's longer than 35. Well done. Is she right, by the way, before I...
Yeah.
Okay, good job, Faith. Did you store that number?
Let's go with it.
Good job. Okay. This is gonna pop up a lot where your variable is in the denominator. You need to know how to solve that. Whether you use the switcheroo or you do the algebraic steps I went through to get that, you gotta be able to do that. So there's a lot going on here. You need to make sure you have a right triangle. You need to make sure that you can identify the three sides, the opposite, adjacent, and hypotenuse. You need to make sure that you can set up an equation correctly. I'm going to be looking for this equation. I don't want numbers appearing out of nowhere. And then you want to ask yourself a simple question when you're done. Does my answer make sense? Is the smallest side opposite the smallest angle? Is the medium side opposite the medium angle? Is the biggest side the hypotenuse? Pregunta.
So if you do the switcheroo, like, what do you do as you show your work?
Nothing. I would accept going from here, from this step to this step, and eliminate that middle step.
Okay.
That's fine.
Okay.
Yeah, the switcheroo is, I mean, it's not a technical term, but it still gets you where you need to go. Any problems with this? Again, keep it as simple as possible. Don't overcomplicate this. I think we might be done here for today. Yeah, we're gonna stop here. What we're actually gonna start with on Tuesday is picking up with the idea of being able to solve for the angles. Because notice in the examples that we did, all we did is solve for side lengths. We want to be able to solve for angle measures. So in a 3, 4, 5 triangle, I'd like to know how big angle A is. And if I can find angle A, then I can find angle P. So we'll pick up with that on Tuesday. On the homework tonight, there might be some problems that you can't solve because I might ask you for some angle measures. If I ask you for the angle measure, just skip it. And make sure you understand the difference between finding the tangent of angle P and finding angle P. You can find the tangent of angle P. How big is the tangent of angle P? What is it? I'm sorry?
4/5.
Nope,
3/4.
3/4. You don't know how to find the measure of angle P yet. That comes on Tuesday. I also have your quizzes, which I'll pass back. We can take a look at those, and then we'll be good to go. Okay? Questions? Outstanding.